teeny on this screen. So this table, to complete it, if it is $5, 18 minus 5 tells me 13,000 downloads for a total of $65,000. So we dropped the price, and what happened to our revenue? It went up. Let's drop the price, or no, sorry, we increased the price. What happened to our revenue? Right, let's increase our price to 10 now.
I think it's the most.
8,000 downloads would be 80. So we charge even more, man. We're breaking it in.
And if you
Let's charge even more and see what happens.
you did 8 times 11, you get 90.
$12 would give me 6,000 downloads for 72. We got a little too greedy. Let's see what happens if we increase it even more. 3,000 downloads for $45,000. Oh, now we're tanking. 0 downloads. Nobody's gonna pay $18 for this junk movie.
No.
$0. So every time to get the number of downloads, we are given the function 18 minus x. And to get the total revenue, we would multiply that by the price per. So I wrote it as x times 18 minus x.
Let's go.
And what should we be looking for to see if this is quadratic? Every quadratic function has this thing we've been looking for, whether it's a visual, whether it's in the pattern. We're looking for a square, right? An x squared.
You can distribute that.
Yeah, there is an x squared here, because this is the same thing as 18x minus x squared. So guess what, friends? Quadratic, son.
I didn't get it right.
That's all right, though. But if you understand why,
Yes.
that's called learning.
Because there's 2 X's.
I learned you real good.
2 X's in the equation.
See the x squared. Okay? That's why. Yeah. Again, plot the points. Use your data and information to make a recommendation of how much to charge for this movie. Taking a look at this graph. I have something like 345, which is, I don't know, like right here. We've got 513, no, 580. Let's say it's right there. We've got 580. 565. Nobody check me on that? 565, somewhere like there. 1080. Well, now we're getting up there. 1272. Somewhere in there. We got 1545 and 180. So, who can make a recommendation? How much do you think we should charge for this movie to maximize our revenue? Zeph, what are you thinking?
So, $10 would make the most money.
Yeah, according to our data here, right?
But $11 would be the best.
11's better?
No,
Yeah.
that would be 77.
I know,
Wait.
yeah, I wanted to say this too.
Okay.
11 times
But
8 is 88, yeah.
In
I know.
theory,
Wait, no,
if it
I'm
were to
thinking
be
wrong.
Brain
become
blast.
a lot more popular, spreading to more people and could possibly make more money, like
Oh.
$5.
Brandon, what money are you thinking?
I was thinking 9.
Yeah, I got 9 as well. I kind of got there by doing this. I knew I was going to square something, right? How do you get the biggest square? The same, yeah, the meeting in the middle, right? So since 9 squares, $81. That's kind of how I got to that $9. But with our data, you can see it happening somewhere in there, right?
That's 77.
Between 5 and 10. Well, how we're going to do this is we're going to roll through the domain first. So thinking about this price and these video downloads, what's the lowest price? Because domain is X values. What's the lowest price?
0.
Yeah, we give them away for free. How much money we make?
None.
None, right? Okay. But what's the most?
18.
What's the highest we can charge? 18. That's also $0 that we would make, right? So this means we can charge $0 to $18. Those are the options. Because more than $18, you get a negative. I don't know. Yeah, $0 to $18 because of 18 minus X part of our function. You can also see that if I go here or here, I'm going negative on price, which means you're going to pay people to download your movie, which would be a bad business strategy, probably. Okay, pay people to download your movie. So
Never pay someone.
next, let's talk about the vertex. The vertex is right here.
It's about 8-ish.
It is the point 981, and here's what it means. charge $9,
Get 81.
get 81,000, and that is the max. In this case, the vertex is the maximum, right? It's at the highest. Nothing else goes above this in our graph forever. Lastly, we have the zeros. Yep, which is 0 and 18, and those are also called the x-intercepts, 0 and 18, and that is when we make no money. Okay? That's what the zeros are. So there's going to be two portions to each one of these when you do it. You're going to get the number values that are the domain, vertex, and 0, but then you're going to use sentences to explain what those values are in context, right? So thinking about contexts we've seen so far, we've seen patterns, right? The pictures of squares. That's a context we've seen. We saw the rectangle maximizing area. We've seen the cannonball, and we've seen dropping the rock off a building, right? So just thinking about contexts, these things mean different things in different contexts, because as you also can see, the technical graph for this goes on forever, but in context of prices and stuff, it doesn't make sense to operate anywhere but right up in here. All right, so get after those next four with your partner, just like this. Checking out our first situation. We have an area of a rectangle with a perimeter of 25 meters and a side length. The domain would be 0, so I'm going to say the length is greater than or equal to 0, less than or equal to 12.5. That's my domain. And what that means is, along the x is my length. Length is 0 to 12.5 as options, something like that. Okay? The vertex is right here. It looks like it's like 6.3 or something, and 39. And in context, what the vertex is the max area at side length 6.3. That's our max area at side length 6.3. And lastly, our zeros. They're right here and right here. Zeros are 0 and 12.5, and that is when 0 area happens. The output is 0 at those points. So the thing I talked about with all groups, and this is going to happen on most of these. So this function right here, could we put a negative number into it if we just had this function?
No.
Yeah, you can.
Yeah, you can, right?
Whatever you want, right? But when we provide context, can we have a negative side length or negative area?
No.
No, so that's why when we... So the domain of like this function or this graph with nothing else would be like all real numbers. It goes left and right forever. But when we provide context, the domain can't be everything because there's no negative side length and negative area. All right. Problem number 2. Number of squares in a sequence. Our domain. Who can tell me the lowest number of squares we can have in a sequence? Zeph?
4 squares.
Okay, sorry. Let me restate. The lowest step number is what I meant to say.
The
But yeah.
lowest step number is 0.
0. So my step number needs to be greater than or equal to 0. So even though there's all this over here, in context, it doesn't make sense. Context. The domain of the actual graph and this function, where I could throw a negative in there and get an answer, would be all real numbers. But in context, the lowest step in a sequence is step 0. Then we have the vertex. So I'm going to write this. Step 0 is lowest step. Okay? Then let's have the vertex. Is our vertex the max or the minimum?
Yeah.
It's the minimum. It's right here.
If it goes
It's the tippity toppity.
It's the bottom.
Well, in this.
I thought you said it was the top.
No,
It was
in
for number
context.
1.
It's like the point.
Number
mean,
1
it's
shows the area, the most area.
I mean, it's just
This one's the minimum.
It's just the point where it curves.
Okay, and what does this point mean?
That means that at around 10,
Lowest number of squares is 4. I know it doesn't look like 4, but I look up at my function. See that n squared plus 1? So that's my vertex. One more thing, zeros. It's not applicable. Right? There's always Always squares. There's never a point where it has 0 squares. I know that because the y-intercept's 4 and it doesn't go down past the zeros. The sequence would look like this. At step 0, I'd have 4. In step 1, I'd have 1 and then those 4. In step 2, I'd have the square and then those 4. There'd always be like that 4. So it never gets to 0. There is no 0. Number 3, distance falling. Negative does not make sense for our domain. It has to be a time greater than or equal to 0. Starts falling after 0, right? Does that make sense for the domain, guys? You can't have negative time. All right. The vertex. It's right here. It's the minimum 0, 0. And what that means is no time, no fall. Okay. And it's got 1 0 at 0. Same idea. No time, no fall. That's our vertex. Maximum or minimum? Minimum. It's at the bottom of our parabola. One more. Height from the ground. Our domain, again, time needs to be greater than or equal to 0. Can't fall until time happens. Next. Next is vertex, max or minimum?
Max.
It's max. It's right up there. Starts at 576 feet. My 0, I've only got 1. Right there. It's 6. It hits the ground there. Why don't we use this one?
Because it's not.
It doesn't work.
It doesn't work.
Yeah, there's no negative time. All right.